Hi, Michael.
Hello, how are you, Marius?
I'm okay. I'm glad that we finally have the occasion to speak face to face.
Face to face, finally, after all these years.
Yeah, we are here in Bulgaria, in Sofia, at the CITES conference, and there have been some interesting days.
There have indeed.
Yeah, but let's start with the beginning. And about RST, your beginnings, how, when, and you are trainer, but also co-author of RST. Can you say more about this?
Well, I first met James in 2001 at a conference. There had been some lead up to that. Apparently we were just going through some archaeological digs, and we discovered that Cem Kaner had brokered an introduction between me and James. Cem had taught a class at my company, and he said at the time, you should meet James Bach. And we sent a little bit of email back and forth, and eventually I did at this conference in 2001. And after a talk that James was doing, I was not a kind of member of the community in any real sense at that point. I went up to James, who was sitting outside of the talk holding forth, and I said, "Hi, James. I'm Michael Bolton." And James says, "Oh, right, Michael. Cem's been telling me a lot about you. What's the hardest thing about teaching software testing for you?" "Fine, thank you. And you, James?" And I mumbled something about I found it difficult to persuade people that they could really learn stuff, that they could really understand stuff if they wanted to. All they needed was better explanations, better framing, some practice in doing it, and so on. And James says, "Yeah, I agree." He says, "For me, the hard thing is teaching the difference between skills and techniques." And I realized what? He said, "Well, you know, people come into my class, they want to learn techniques. I want to teach them skills." And it occurred to me, I'd never really thought of that. I hadn't considered the difference. So that was the first immersion into that world, where we're going to break down things that we might assume are the same or similar that we haven't really thought of. Then somewhere along the line, I believe Cem invited me to some of his workshops on teaching software testing, and I felt very sort of honored to be there, because it seemed a fairly rarefied community. James was there, Cem was there, and we went to a couple of those. I met Ross Collard, the late Ross Collard, whom we miss, at one of those conferences. And then sometime in 2003, I got a very peculiar message from James. He said, "Why aren't you more famous?" That was it. That was all that was in the message. And I wrote back, I said, I don't know, lazy, I guess. I mean, I don't have any kind of profile. I'm working on writing a course about software testing. And James says, in an email reply, "Tell you what, you can teach my course. I'm busy doing that, and I've got more work than I can handle at the moment. You can teach my course. All you have to do is teach it to me once." That's what he said. So I said, "Well, that sounds kind of interesting." So I went to his place at the time he was living in Front Row, Virginia, and I went downstairs to his basement, where he kindly put me up, and I don't know how long it lasted, but maybe half an hour or something like that. I read his materials. I tried to teach him his course. And he paused and stopped, and we went through it, and he led me through a bunch of the exercises, because those weren't obvious from the materials. And in the course of our discussions on those 3 days, he said he thought he had a problem that maybe I could help with. He needed exercises. And that's what he really wanted to figure out, was how to put good exercises into the class. Because, of course, looking around at the time, back then, Even today, very few testing classes have actual testing exercises where you try to learn something, where you try to discover something. So somewhere along the way, James decided that I was ready to work for him in Bangalore, in India. HP was one of his big clients. And so he invited me to take a class with a group of students in Bangalore. That was my first experience actually teaching the class to somebody else. And it was weird because it was in a bank vault, an old bank vault. It had been an old bank, and HP had converted it to a building for their testers and developers. And so we're downstairs in this bank vault, rows of 1 and 2 and 1 and 2 and 1 and 2, all the way back. And that was a really interesting experience. There was a bit of culture shock because I'd never been to India before. And the scariest thing was, at one point, here we are in this bank vault, big old bank vault door on it, and the power goes off, because this happens in India. So I have this memory of these rows of people in a room lit only by the light from laptops. Along the way, I got a couple of people approached me and asked if I would teach the class. I did have a bit of a profile on the web, and one of them showed me this puzzle based on trying to identify a pattern in a set of dice. And so that became the sort of now legendary dice game, which James, by the way, dismissed at the beginning because he didn't see how it could be a testing exercise. It was just a puzzle. Somewhere along the way, though, we found that, we could do it with real dice, with actual dice. So it was physical and tangible. And so James said, well, here's how this works. You try it out, and if it works, then we'll talk about it, and we'll see if we can make it a regular exercise in the class. Which we did. And then the way things work sometimes, at that time we weren't big on Zoom or Skype. It was video conferencing was not really very stable or easy to do. So I got a chance to see James teaching the dice game, and he had turned it into a real testing exercise, because what he had done is the game comes with rules. You're supposed to know that. What he had done was he had encouraged testers to break the rules, to get around the rules, to get around the constraints. That's a big part of what we teach in our classes, is how to get around the constraints of a situation. At one point, James declared, okay, I love this exercise. So I thought, okay, we're good. By 2006, at Consultants Camp, James says, okay, you've contributed enough to the class, and we had talked and argued about things in the methodology and in the teaching of it. We had talked enough and argued about it that he said, all right, you're a co-author of the class now. And that was, I guess, 17 years ago. And so I've been running around the world ever since, and for a couple of years staying at home as well.
You mentioned arguing, so this kind of dispute, semantics matter a lot.
Absolutely.
But in the same time, you also complement each other, you and James. Can you a little bit touch on this?
Compliment.
Yeah.
No, it's compliment. You're just you're such a nice guy, and you're so good looking.
Not compliment.
You've lost a lot of weight lately. Yes, compliment. We are different personalities. I'm somewhat irascible, but James is a good deal more irascible than I am. A sort of emotionally driven. James claimed to me at one point that he was an extrovert, and I thought, well, okay. I mean, he's a sort of big personality, but then after watching him in social interactions, it didn't take very long for me to figure out he's actually really an introvert. He has fantastic energy in classes, as do I, but for me it fuels me, and for him it kind of drains him. At the end of a class, he's tired and he wants to kind of retreat and process the experience he's had in teaching the class and then interacting with people. But I'll go out to the pub and I'll close the bar with the people. So in that respect, we're different, and we can keep following a Myers-Briggs pattern. We talk a bit about that afterwards if you like. But James is much more intuitive, model-based, metaphorical than I am. I love a good metaphor. I love a good analogy. But James is extremely adept at producing those quite spontaneously. He's also very good at diagramming and modeling. He's kind of Mr. Model. I'm more into the data. I need you to show me stuff. I need to see it happening in the Myers-Briggs sense. James is an N and I'm more of an S. Not a terribly strong S, but more of an S. James is a Myers-Briggs F, driven by emotion and driven by how he feels about stuff. I'm much more up in my head, much more a T on the Myers-Briggs scale. Finally, here's how we don't complement each other very well. We make terrible problems for each other ourselves. Neither one of us is a Myers-Briggs J. That is to say, we're not inclined to see an endpoint for something and declare something done, which is actually kind of useful for testing, right? Because testing is never done; it only stops. But we are both, I think, off the chart Myers-Briggs Ps. The official lettering for it is perceiving versus judging, and nobody ever knows what that means when you first see the words. But what it means is, do you have an open-ended sense of things or a finality kind of end of things? And James and I are never done. She's anything in a funny kind of way. So those are the complements. Now, as the Myers-Briggs S, it's exactly the sort of thing a Myers-Briggs S would say. You shouldn't take Myers-Briggs too seriously, I don't think. It doesn't have a really strong scientific basis, but it is, for me, a useful model in this sense, explicitly. It reminds me that other people aren't like me and that I'm not like other people. It has about as much scientific solidity as horoscopes do. But it's still useful in being able to paint in broad strokes how you might perceive differences, complementarities, comparisons, contrasts with other people. So it should not be used as a sentence or as destiny or even as something particularly conclusive, but as a useful kind of metaphor or tool for the way people go about their day, the way people think and feel and so on. It's a reminder of our some interesting potential polarities on which are all a spectrum.
You are different, James is different, Paul is different, Hype is different, Griffin is different.
Yes.
But still, when you are doing things in RST, there is a common foundation, common grounds.
Mm-hmm.
So your differences, in a way, will manifest in those roots of RST. What are those? The pillars, which are very important in RST.
The foundational kind of premises, the things that we all agree on? Okay, so number one, there's a blog post about it, that software testing is fundamentally a human activity. Software development is a human activity, and as such, it is beset by human frailties, and it's also empowered by human strengths. So the example we give is, so a project manager may dismiss a bug because he doesn't like you, or a developer may dismiss a bug report that you've submitted because he's busy, or a a designer may not follow your logic because she had a bad day yesterday. And we've got to be super tolerant of that and super aware of that because it's fundamentally about people. On the other hand, people are the source of our strength as well. So the fundamental humanism, the fact that we're all vulnerable to errors systematically and spontaneously. And it's our job as testers to serve our clients in helping them to perform the fastest, least expensive testing that we can do, and to focus on cost and value. The idea that sometimes we have to do deep testing, but we won't prescribe a $10 million test when a $10 test will do. That we will not knowingly or negligently mislead our clients or ourselves, which means we have a different approach to measurement and metrics than we hear a lot about. Most of them are kind of bogus, but we are absolutely willing to assess things, be very careful about trying to measure them, especially human performance. And we got a lot of that grounding in that from Jerry Weinberg and from Cem Kaner. We took the humanist aspects of what they were talking about in software development and software testing, and we applied that to our work. And we used to be colleagues, Cem and James and I. We're not anymore. We're kind of sad about that. We're not colleagues with Jerry anymore because sadly he's passed away. But we believe and hope that we're continuing the principles that they steered us towards, and we're trying to honor that. So that's one thing that all 5 of the RST instructors have in common.
You mentioned measurements and metrics, and I heard these days, and a lot of time is that we measure to know where we are and where are we going. And I was thinking to kids, and when we raise them, we don't do that.
No.
And it's strange, and because this is one thing, and then I heard about measuring productivity, which for me it's a big ways to do that. I mean, is the strata variation principle. I'm scared about that when a measure becomes a target. It chooses to be a good measure.
Is that good?
They will game it.
Yeah.
They will game it, and I think especially in testing, it's not so okay applied, this kind of measurements.
I mean, if you want to measure productivity, go ahead, but you run into the kind of error. I heard a fellow named Russ Roberts does a podcast called Econ Talk, I think. He's about to release a book, or he just released a book recently, in which he pointed out the error of taking a matrix and turning it into a scalar, which means a table of things and trying to render the table as a single number. You're going to lose a lot of information. You're going to systematically ignore stuff. You're not going to be able to ascertain from that single number, that scalar, what is productive and what is not so productive, what is waste and what is not waste. Because it seems to me there's no coherent model for productivity, or the way the qualitative researchers would put it. How do you operationalize that? What's the way in which you say, all right, let's represent productivity as a number somehow. Well, what's the operation by which you do that? The set of observations you make, the mathematical function that links the observation to the number, and that's just nowhere in most software development measurements and software development metrics. It's a problem of construct validity, and Cem, in collaboration with Pat Bond, wrote a fantastic paper on that, which I wish more people knew about. that's just one aspect of the things that we try to encourage people to avoid, is evaluating things based on numbers. But assessments are really powerful, because when you assess something, you're trying to determine what you like, what you don't like, how much you don't like it or not like it. Not rendering it as a number, but saying there's a bunch of factors I want to look at. For example, in productivity, people can be really productive in terms of, let's say, writing lines of code. But is that code useful code? Is it good code? So now we have to assess that. Is it overly elaborate code, or is it nice, clear, simple, readable code? Is it modular code? That's one of the reasons why lines of code measurements and metrics don't work. It's an example.
And we have another example, like the counting of test cases. For me, it's like a reification error. But RST offers, like, for example, session-based test management, and to avoid that kind of the reification fallacy.
I love that you bring that up, Marius. I love that you remember that, because that's one of the things very early on. I love to hate reification. That is the idea of turning abstract things into treating them as though they were things, treating ideas as though they were objects, and that was a really big theme that ran from the very beginning all the way through my take on RST. Let's remember that ideas are ideas, that a test is not a test case. A test is a performance. A test is an activity engaged in other activities. And reducing testing to test cases essentially focuses on the artifacts. You know, it's like nobody goes to a newspaper reporter and says, evaluates the quality of the report that the reporter is providing in terms of the number of paragraphs. It's what's in the paragraphs that count. I mean, a profoundly important story might be a magazine length article, the big article in the New Yorker magazine, or it might be a two-page account of, or a two-paragraph account rather, of some incident. The context of the piece and the context of the story dictate the value of it and the significance of it, the importance of it. Which leads to another thing, clearly not doing very well here, is the skill of summarizing, expanding and refining, contracting, elaborating, the alternation between those things. That's another pattern in RST, the idea of alternation between things that could be important.
And I have to mention, yesterday we discussed about audits and the work of James Christie, and how they, after the 2008, they revised the things with audits and they concentrated on principles when they do the evaluations, no longer rules.
This is what I've learned from James Christie, yes, and I wish I were a better student of his as an auditor for big companies, including IBM. He's been following the linkages, the parallels between the testing business, such as it is, and the audit business. And that was a really important thing, yes, that they decided to evaluate companies as auditors instead of basing the audit on how well the companies followed the rules, on how companies were applying principles.
And this is related also to the test cases.
Very much so. Very much so. A test case is not a test. And it's one of the more frustrating things to me to see at conferences and in blog posts and in talk about testing, how testing gets reduced to test cases. But another element to that, I suppose, is really important, is when we talk about a test case, what are we actually talking about? Now, my objection to test cases is the reduction of a test, the performance of asking a question, modeling the test space, identifying risk, modeling coverage. But what does this test, what does this performance cover? What is explicitly covered and what's incidentally or accidentally covered as we perform the test? A test case it doesn't speak to that.
And I noticed something strange also. So it's the test cases, and then a notion, I saw it in the context-driven community, test charters. And recently I saw them put them together, and a little bit I got scared because it was like, let's validate test cases also in that part where we use the charter things. Maybe I got it wrong, but still some warnings were triggering me.
Yeah, well, as a context-driven tester, as a member of the context-driven community, I'm not allowed to say don't use test cases.
Yeah.
It's just, sometimes there are circumstances in which test cases are useful, but I prefer to think of them as specific things that must be checked against some explicit oracle, typically using some explicit procedure. And it can be quite reasonable to do that. What I worry about is the tendency to ignore everything else about the performance of the test, including who the tester is, what the tester does, what their skill is, what their relationship to the product is, how conversant they are with the domain in which they're testing. The idea behind a lot of formally structured, excessively formal, procedural test cases, the idea is, well, we want it so that anyone can do it. Well, no, I don't want anyone testing my product. I want a skilled, engaged tester testing my product if I'm a program manager, as I was. I want that tester to have the freedom and responsibility.
Agency?
The agency, exactly, to improve the test as the tester goes, to evaluate at any moment where the tester's at, to make a decision as to what to do next. That's the fundamental principle behind our current view of exploratory testing. It's all about agency. It's all about the capacity of the tester in the moment to choose his or her next action, next thought, next question, next evaluation. Because testing is really fundamentally a process of learning about the product for the purposes of, principal purpose most of the time, of finding problems that matter and that threaten value. So.
There is another sensible subject, I saw it. It's about requirements and planning the testing strictly based on requirements. As everything, it's very deterministic. Isn't this dangerous? I mean, even before interacting with the product, no, let me have the requirements and do the planning. What we miss here, what might be problematic?
Well, I remember Paul Holland talking about an exercise that he did with his testers, when he was working at Alcatel-Lucent. He handed them, he described the product to them. He might have given them the product, but he certainly, the first thing he did not do, what he didn't do is give them the requirements documents. I think he described a feature, a function, and idea after idea after idea after idea came out. And then he put the requirements down in front of the testers, and he said the flow of ideas went from a fire hose to a trickle. Because I think the way he tells the story is that they started focusing on the explicit instead of the possible. They started applying what was explicitly written in the requirements document to their design or to their planning or to their strategizing. instead of applying tacit knowledge about the domain, which they had loads of. They were skilled testers, experienced testers. So, if you've got a requirements document, you might want to start with that. You might want to read the requirements document and understand something about what the designer, or the developer, or the commissioner of the project, how they intend to get value out of it. Well, that can be all right. Of course, what's in the requirements document, another case of reification, that's not the requirements. That's a subset of requirements. That's somebody's idea about what the requirements are and the stuff that they've written down explicitly, not the stuff that's tacit in their heads. It's what they thought the requirements that were important to write down were on such and such a date. So as soon as the requirements documents hit paper or even a computer, they are to some degree behind the curve. They're late. They're frozen, time bound, which is what the people from the general semantics movement might say. So let's avoid reifying requirements as well. Planning your testing in a way that says, well, in medical testing, there is a kind of formal testing that is based on requirements, that each requirement must be reviewed and that each requirement must be tested. So, wait a second, if that's true, why not do this? Why not take the requirements document and cut it up into little slips and say to a tester, test that. And if there's specific things, specific procedures that we want the tester to follow, you can include those. If there's specific things that they must observe, you can specify those. If there are a specific order of doing things, the tester can do those. But you can write it down and insist that the tester do that. But you can't stop there, it seems to me, because what you need to do as the tester is to discover what the requirements documents aren't saying, what the product is doing that nobody thought of, that nobody discovered, what the product is doing right from a certain perspective that might be not so right from another perspective, from the perspective, the variation between novices and experts in the use of this particular product. Somebody who has prior experience with the product versus somebody who has no experience with the product. Somebody who is very careful and very thorough and very methodical when using a piece of software, and somebody who is under pressure or in a rush or careless or prone to mistakes. It seems to me that most test plans that focus on explicit requirements and test cases are going to miss all kinds of those sorts of bugs.
They want to get it right for the first time, but they don't let a place to fail in a safe way.
Yeah. One of the things that we refer to in rapid software testing explored, at least these days, and I think in applied as well, it has bubbled up over the years as another one of those things that we've discovered, is something that we call the bootstrap heuristic. Every engagement with a product for a tester, or a new function or a new feature in an existing product, or a new perspective, a new take on data, involves some degree of bootstrapping, starting from a position of innocence with respect to this new feature or function and moving to experience. So the getting it right the first time is a very interesting thing. It seems to us that to some degree, when you encounter something, you are seeing it for the first time and you don't know whether what you're going to do is going to be right. Right? You can't simply create a set of test cases for a product and expect you to take it to each unknown bug. Every thing that we care about that is done well and efficiently starts off as being done poorly and inefficiently. I mean, the whole history of engineering is like that.
Yeah, we realized that an experiment that didn't succeed, it actually it will help in the growth.
Help?
In the growth of ideas and what will follow.
In the growth of ideas, right. Every new thing that we do, and we're always doing new things when we're testing something new, because the product is in some sense new. It can be a greenfield product, or it can be a new feature in an existing product, or it can be a bug fix for a product that's been around for a long time. We need to develop a mental model of that thing, that target, that the object of our study, the thing on which we're going to focus attention. And by thing, I mean it's quite abstract sometimes, an idea or concept. So you can start off knowing the domain. That will save some unnecessary confusion. You can start off knowing something about technology. That helps to relieve some unnecessary confusion. You can start off by knowing something about testing, and that helps to relieve some unnecessary confusion. But the conjecture of necessary confusion is that there are some things in the world, lots of things in the world, lots of experiences we have and learnings that we develop, for which there is no algorithmic resolution. And what I see in a very test casey approach to things, a lot of the times when testing is overly formally, procedurally structured, is an attempt to turn a test into an algorithm. But a test isn't an algorithm. A test is a heuristic for learning something about the product or finding a problem in the product. So that can't be algorithmized, with one notable exception, and that is what we call a check, where there is a procedure for collecting observations of the product, for interacting with it in specific ways, and then applying decision rules to the observations that we've made, and then relaying the outcome of those decision rules to a human, all by mechanistic, algorithmic,
deterministic.
And quite deterministic, although there are certain kinds of exceptions. For instance, we could randomize the data that is part of a check, but then we would need an algorithm for comparing the output of whatever the program is producing with some oracle, something that would alert us to an inconsistency somehow. Well, a check can be made subject of an algorithm. A check is an algorithm in a sense, in a very real way. But how do you get to that? There's no algorithm for creating algorithmic checks. It's ultimately everything's wrapped up in heuristics, in a fallible means of solving problems. So that's what I worry about with test cases. It's an attempt, a test casey approach is an attempt to reduce this vast, heuristic, somewhat confusing, somewhat daunting, complex, socio-technical world that we're living in to a set of algorithms. And that's not, it'd be a great idea if it could work. Jerry Weinberg had this wonderful thing. I was listening to an old podcast the other day, and Jerry's reaction to it was always kind of, he starts with a bit of empathy. Wouldn't that be a great idea? Wouldn't it be great if we could do that? And here's why we can't,
And organizing doing a test plan based on that, it might be disastrous. And then I also notice another subtle difference with requirements. They want it like, you know, to be sure they cover everything in that requirement. Like there is no tacit knowledge, that like there are no mental simulations or metaphors or something. They really believe that they can cover it. In a way, it's nice that they try to do it, but to express it like, hey, it's possible, it's a totally different thing.
I don't quite ever understand what people mean by everything. You know, surely to goodness, when we say we're covering everything in the requirements document, well, how do you model everything? It's always a modeling process. It's always a process of performing helpful, useful simplifications of what the requirements actually represent, in the knowledge that what the explicit requirements represent is only a subset of what the actual requirements are. And very often when we're testing, we discover that the product cannot fulfill what somebody purports to require from it. So we say, well, this is the best performance we can wring out of this product, or so it seems, or the product falls over at this, under this load, or the product has a hard time handling this kind of data, and people will say, yeah, all right, we can live with that. So it turns out not to be the requirement, in the end, because we don't know what the requirements are. Not really, not completely. We never know them completely. We never know what we can get, what we can get away with. We're never clear on what we want. My wife, Mary, is a website designer, an interaction designer. And like every other designer on the planet, she will tell you that the client never knows exactly what they want. And after you sweat your work for hours and hours and hours, and you produce something, and you show it to them, and this is what you said you wanted, and they say, no, but that's not what I want. We have limited imagination in terms of what the world is going to look like when somebody produces something, when somebody makes a change. We have a vision in our minds of what it's going to be like, and then when we see it, we have a better idea of what we might like or what we don't like. And this is the particular hell that designers live in all the time, because people genuinely can't know exactly what they want, and even if they do, they can't express it very well. And that's the designer's hell, but it's also the designer's art. Same with software developers, same with programmers. Somebody specifies, we need this algorithm to produce this kind of output. And so the programmer diligently sits down and writes some code to do it. And the word comes back, yeah, but that's not fast enough. So the programmer goes back and tries to optimize it, and then they say, oh yeah, but it's also supposed to communicate with this other API, with this module. And so the developer sweats, and she tries to write lots of lines of code to make it work with this API, and then somebody comes along and says, oh yeah, but we're upgrading that API, and we're deprecating this function in it, and that's going away soon, and oh, this one's already gone away, and welcome to software development, and testing has to respond to that. And so we have to find out enough about the product quickly enough to identify the important problems in it. And so whatever we're doing in terms of time-binding stuff, writing stuff down, creating test cases, creating test plans, we've got to do so in the full knowledge that it's going to change, that it's going to get revised. That was that's the subtitle of what is, most people would agree, the first book on agile software development, extreme programming, embrace change.
And not only this, our understanding changes.
Yeah, right, absolutely. As we learn something, our our appreciation of it, our apprehension of it, our comprehension of it, our approaches to looking at it, the angles from which we realize we can see it, the interfaces that we might have or that we might want, all that stuff is changing all the time. And the old approaches to, the heavily formalized approaches to testing, which crept up, I don't know, somewhere in the 70s and 80s and 90s, all these formal things, you know, they kind of work okay for checking the output of algorithms, but for testing a product that's going to be used by people in this, as we emphasize, socio-technological domain, they're not going to work.
They ignore this dimension of tacit knowledge.
They ignore tacit knowledge. They ignore change over time. They almost universally fail to consider the rich range of people who might be using our product. And you only have to say the words accessibility testing or security testing in terms of people who use our products in malicious ways, or usability of various kinds. Sometimes we can depend on a certain kind of what Harry Collins would call ubiquitous tacit knowledge. Everybody, for some value of everybody, knows how to use a computer. Everybody knows how to use a Windows interface. To some degree, that's kind of ubiquitous. But does everybody know that business where you slide something to the right, a feature which on mobile phones is consistently hidden? It's there to be discovered, and it's not documented any place that I'm aware of. You know, it's just sort of there, and people find out about it by accident, or by asking a teenager, or these things aren't exposed to the end user. And a lot of the problem with this is that the product follows the builder's knowledge and the builder's intentions, but the people who are using the product are on the outside of all that. They don't know that feature is there. They don't know that function is there. They don't realize how important a particular function might be. For instance, in the very software that we're using to record this interview, I looked at a meter that was recording the audio, and I failed to notice. It became quite obvious after a while, but until I had a bad experience with the sound was clipping, it was distorting because the volume setting on the microphone was too loud. I didn't even realize that feature was there. I had to go looking for it. It's part of our job as testers to help the builders come at the product from a different perspective, from the outsider's perspective. Because it's really easy when you're building something to get immersed and over-focused in your model of it. And that's why one of the reasons why testers are important. We're there to provide a perspective of the product at some critical distance, at some domain distance, at some social distance that's different from the builder's mindset. That's something we talk about a little bit in our material. I'm not sure either one of us has ever explicitly written a blog post on critical distance. People learn about it in the classes. And so there we loop back to the James and I, the P. There's all, if you walked into our mental shop, you would see stuff all over the floor and stuff hanging on hooks and stuff that's been half painted because we got distracted by this other thing that we were going to do. So it's all about change. It's all about realization and evolving models of the world and evolving models of what we do. And we think that that is normal and natural and healthy.
I keep hearing about, I will change a little bit the subject, about positive and negative testing.
That came up a couple of times in the last couple of days at the conference. This is a trope in testing, the idea of positive and negative testing, and sometimes we see this expressed. I can't think of an explicit example right now, but it's sort of one of those things that appears to be out there in the air. In certain places, in certain circles, the idea that there should be one positive test and one negative test per requirement, which seems to me posits the idea that there's only one thing that can go wrong, first of all. But then if I probe a little bit and ask people what they mean by that, I feel like I don't get a quite coherent answer. And the example I use is, all right, supposing we put in some input where there's an explicit requirement, the product shall accept only numeric input, digits from 0 to 9. Okay. And if you don't do that, an error message is supposed to come up. Okay, so if you put in something else. So you put in something else. With respect to 0 to 9, is that a positive test case or a negative test case? And they say, well, if you put in 0 to 9, that's a positive test case. We could put in the slash. Is that a positive test case or a negative test case? Well, that's a negative test case. Okay, so I put in a slash. The error message comes up just like it's supposed to come up. Is that a positive test or a negative test? And at that point, there's a expression Keith Klain loves to use, which is the RCA Victor dog looking in the megaphone, in the gramophone. So what we would say to help clear things up, we try to have a sort of coherent model of stuff. Whenever we use terminology or something like that, we try to get to the heart of what we mean. Now, people don't have to adopt our language, but they don't have to adopt our label for it, but it seems to me really important that they have a coherent model in their heads for what it is. So what we would say is that a positive test is one that honors every explicitly declared requirement, or sometimes we might say test condition. And a negative test, we might say, is one in which we systematically violate at least one explicitly declared condition. And then we sort of push it aside and say we don't really think positive and negative test case or positive negative test is a terribly useful concept, because a lot of the time the output of such a thing is deemed to be a pass or a fail. So we try a negative test case and the product sort of stands up to it, and so we deem that a success, a pass. But wait a minute, how many explicitly declared requirements can we violate in a single test? And while we're at it, what about all the undeclared requirements? What about the tacit requirements? What about the requirements or the conditions that you're not monitoring in the test? There's a zillion ways that things can go wrong in practically every test idea. You can see some measure of success. You say pass when what you really means is it appeared to work. It appeared to meet some requirement to some degree. That time that I did this stuff with these explicit inputs on this particular Thursday on my machine, So there's that's all a test can ever tell us. It can tell us that something did appear to work. Can't tell us that it did work because of all the observations that we could make that we didn't make for logistical reasons, or for the fact that you can't observe everything. You can't observe the internal state of the machine. So what we're really saying when we say a test pass, we try to resist that kind of language. But when we say it appeared to work, what we really mean is none of the oracles that we have available to us, or that we had available to us at the moment of the test, fired and told us there's a problem here. Right? Whatever problems there might have been in the product just got away with them. You know, but that doesn't say that the product will do that again. We would have to do it again to find out if it were going to do it again. And it doesn't say that there's some aspect of the product that has failed in a material way that we haven't noticed. And that means that testing is actually mind-bogglingly rich and hard. Because of all the observations we could make, we have to sample those. We have to model that space, perform useful simplifications on it. That's why I think I'm growing to believe that it might be a mistake to hire young people as testers. I don't want to go too far with this, of course, but as somebody who doesn't have experience with technology, with the domain, with how they can be fooled, is subjectively, with subjective testability, not in as good a position as somebody who's been burned a few times by experience. And of course, how do you get that experience? By starting as a young tester and getting to be an older tester, or by hanging out with older testers. And by older, I mean people with more experience. When it comes to training new testers, one thing I see that's kind of worrying is that new testers are immersed in cultures where maybe the testing isn't so great. And they learn from immersion in that culture not how to do fabulous testing, but how to do adequate testing, where I'm diminishing adequate.
Thank you a lot, Michael. It was
Marius,
to speak with you.
I want to say thank you to you, and I'll get mad if you edit this out. I just am so delighted to have your help and your perspective in helping us get these ideas across. You are doing far better than marketing of this than we've ever done on a certain level. And this series of videos I think is tremendously helpful. And I'm also very grateful to have in our community somebody who's bringing the developer's perspective, the committed developer's perspective to honoring testing work. And that for us is a real honor and a privilege. So thank you for that.
Thank you.